Hello, welcome to Organic Chemistry. I'm Mr. Collard. In this video tutorial, we are going to conclude our discussion of organic functional groups by discussing amines, amino acids, and finally amides. Let's begin our discussion with the amines. Amines are a derivative of the ammonia molecule, NH3. An amine is formed when an alkane and an ammonia molecule both lose a hydrogen atom and form a single bond with the unpaired electrons. And to illustrate that, I'm going to use Lewis electron dot diagrams to describe the formation of a one-carbon amine called methanamine. First, methane. Combining with ammonia. Now what's going to happen here is that the hydrogen atoms are going to combine to form a hydrogen molecule, and the leftover unpaired electron from both the methane and the ammonia molecule are going to form a single bond to form the amine. I'm going to highlight the electrons from both methane and ammonia that will make the new bond. Okay, so the amine product is called methanamine, and this is its Lewis electron dot diagram. And a hydrogen molecule is formed. To name an amine, the E ending from the alkane name is changed to end in amine. This structure here would be a methane. Drop the E in methane and add the ending amine to make methanamine. Let's draw a structural formula for methanamine, ethanamine, and 2-propanamine. Methanamine has one carbon. And for simplicity's sake, I'm going to condense the NH2 amine group like so. Now this is a structural formula. To write a condensed structural formula, I'm going to use the similar pattern to what's written on table R for the example for the amine. Molecular formulas are simply total number of carbons, hydrogens, and then other elements, in this case, one nitrogen. Let's write a structural formula for the 2-carbon ethanamine. Now for ease of writing the condensed structural formula, I just put the amine group here on the carbon on the right. We know a number is unnecessary in the name because any way you rotate this structure, the NH2 or amine group will always be considered to be on carbon 1, and there should not be a number written in front of the word ethanamine. Let's write a condensed structural formula, working from left to right, and a molecular formula. Now if we look on table R, we see the example is 1-propanamine. Therefore, there must be a 2-propanamine. 1-propanamine and 2-propanamine must be isomers, as they'll have distinct and different structural formulas but the same molecular formula. There is no such molecule as 3-propanamine, because if you rotate that molecule 180 degrees, 3-propanamine is really 1-propanamine, and low numbers for functional groups always win out. 3-propanamine does not exist. There are only 1-propanamine and 2-propanamine as isomers. Let's draw a structural formula for 2-propanamine. And let's condense that. Now if we look at the amine group on carbon 2, we could put this amine group in parentheses for clarity, although it's not necessary to do so. Molecular formula? Let's examine amino acids. Amino acids contain a carboxyl group, which condenses down to COOH, and an amine group, or NH2 group. The amine group is attached to the carbon atom that is adjacent to the acid group. The remainder of the molecule is represented by R, which indicates a side chain. And there are 20 amino acids with 20 distinct side chains. You are not responsible for drawing them or memorizing them in this course. Amino acids are the building blocks of proteins. So here we have a central carbon atom. We have an amine group here. We have a carboxyl or acid group here, and we have a R group indicating one of the 20 specific amino acid side chains. Finally, we have a hydrogen atom bonding to the central carbon, and that is the basic structure of an amino acid. So let's draw the general structural formula for an amino acid. We have a central carbon atom. We have an amine group. We have a carboxyl or organic acid group, the R group, specific for one of the 20 amino acids, and finally a hydrogen atom, completing the bonds to the central carbon. Here's a specific amino acid called alanine. In the case of alanine, the R group is simply a 1-carbon methyl group. You are not responsible for memorizing the 20 amino acids and their associated side chains in this course. Let's examine the final functional group listed on Table R called an amide. One of the hydrogen atoms of the amino group reacts with an OH of an organic acid, and a condensation polymerization reaction occurs. This reaction produces water and an amide, which is a compound formed by the combination of 2 amino acids. Long chains of amino acid molecules are held together by peptide bonds and eventually build proteins, which are longer chains of amino acids linked together with what you called in living environment a peptide bond, and in this course we're now calling an amide bond. Let's look at the formation of an amide bond between 2 amino acids. This you'll recognize is amino acid number 1, and this is amino acid number 2. And here we have the organic acid group of amino acid 1 and the amine group of amino acid number 2. And we're basically going to take the OH off of the organic acid group of amino acid 1 and the hydrogen off of the amine group of amino acid number 2 and make a water molecule. And we again can see that here, where the water is coming from. Here is the amide bond, linking together the first amino acid and the second amino acid. If we repeat this process over and over again by linking more and more amino acids together, we make what's called a polypeptide chain, or many amino acids strung together to make a polymer, which is a polypeptide chain, which goes on to build a protein structure. What did we learn in this tutorial? We discussed amines, amino acids, and amides. Need more help? Please contact me. Have a great day.